Okay, so now we're going to start talking about the different types of bonds that can form. And the first type of bond that we're going to talk about are covalent bonds. And recall that we said that we can use electronegativity values to figure out the type of bond that's going to form. And we said that if two atoms have similar electronegativities, neither is stronger than the other, so they're going to share electrons equally, and that's called a covalent bond. So when two atoms form a covalent bond, it's because their electronegativity values are similar, and they're able to share those electrons equally. Neither one of the atoms is stronger than the other, so neither one of them pulls those electrons any more than the other atom. And so now we're going to look at some specific examples of bonds, and we're going to show how we can show a covalent bond. Let's see if we can go back to our screen here. And so the first example that we're going to use is hydrogen. So we're going to look at a bond between a hydrogen atom and another hydrogen atom. And so we're going to be looking at a bond between two hydrogen atoms. So the first thing we want to do is we want to look up the electronegativity value for hydrogen. And so the way that we would do that is we would look in your book. On page 127, there's a periodic table, and on that periodic table are electronegativity values for each of the elements. And so your book says that hydrogen has an electronegativity value of 2.1. So I would assign a value of 2.1 to this hydrogen atom, and I would assign a value of 2.1 to this hydrogen atom. And so I'm going to calculate the difference in electronegativity so that I can see what type of bond is going to be formed. And so the way that I would do that is I would just take 2.1 minus 2.1 equals 0. I know that 0 is less than 0.4, and so I know that the type of bond that's going to form is a covalent bond. Okay, so when I draw my two hydrogen atoms bonding together, I'm going to show that they're going to be sharing electrons, and they're going to be sharing their electrons equally. So the next thing I'm going to do is I'm going to draw the Bohr model of the hydrogen atom, and I'm going to show how they bond together. And so my first hydrogen atom, I'm going to go ahead and I'm going to draw it in blue. And so I'm going to start with a nucleus. And I know hydrogen has one proton. Hydrogen is such a small atom that it doesn't even have a neutron in it. All it has is one proton. A neutral hydrogen atom, therefore, also has one electron. And so I'm going to go ahead and I'm going to draw my first energy level, and I'm going to draw my one electron that this hydrogen atom has. Okay, so there is my first hydrogen atom. Now I'm going to go ahead and I'm going to draw my second hydrogen atom, and I'll go ahead and I'll draw it in red. So I have another hydrogen atom over here, and so I'm going to draw its nucleus. It's going to have one proton in it, and it's also going to have one electron. And so what you should notice right away is that each of these hydrogen atoms, they're not happy yet. They don't have a full valence shell. So hydrogen only has the first shell, which means that it's looking for two electrons in that first shell. So it's going to want to bond with something else so that it can fill its shells. And when two atoms bond together, each of those atoms has to get something out of the bond. So the bond has to help each atom fill its valence shell or get closer to filling its valence shell. So what we're going to show, we know that we have a covalent bond if two hydrogen atoms bond together because the electronegativity difference is 0. And so what we're going to show is we're going to show how this bond would look like. And so what I'm going to do is I'm going to erase this second hydrogen, and I'm going to move it over. So now that you know what it looks like, let me go ahead and erase it from here. And I'm going to show it. It's going to get really, really close to my other hydrogen atom because in order to bond, they actually have to be really close. So I'm looking for my pen here. And so now here is my nucleus of my second hydrogen atom. And here is that first shell. And so you notice that my first hydrogen atom, which was the blue one, is now sharing an electron with the second hydrogen atom. But you should also notice that my second hydrogen atom is sharing its electron with the first atom. And so by each of them sharing an electron with the other atom, they're each able to complete their valence shell. This blue hydrogen atom now has 2 electrons in its valence shell. It has the blue electron, it has the red electron. The red hydrogen atom also has 2 electrons in its valence shell. It has the blue electron, it has the red electron. So by sharing an electron with each other, they're able to complete their valence shells, and now they're happy because they've achieved a lower energy state than they had before. And so if I, let me kind of show you something. And so actually this here is the bond that's formed. This pair of electrons that these 2 atoms are sharing with each other, that is the bond, and that is actually a single bond. Okay, 1 pair of electrons that are shared forms a single bond right there. Because the electronegativity values for each of these hydrogen atoms are similar, and actually they're equal because they're the same type of atom, they're going to be sharing the electron equally, which means that there's not going to be any region of any charge imbalance or any region of negative charge or any region of positive charge. Those electrons are shared completely equally, and so if I had to show this molecule overall, it's going to look like this. There's no positive or negative charges that kind of stick out anywhere in that molecule, and so this is a covalent molecule. And this here shows what the bond looks like. It shows how those 2 atoms are sharing their electrons to form this molecule. Okay, so let's go on and let's try another example. So our next example is going to be a chlorine atom. Oops, sorry about that. A chlorine atom bonding with another chlorine atom. Okay, so we're going to look up the electronegativity value for chlorine. And so according to our book on page 127, the electronegativity value for chlorine is 3.0. And since we have 2 chlorine atoms, they each have an electronegativity value of 3.0. So I'm going to figure out what kind of bond these are going to form, and I'm going to do that by subtracting their electronegativities from each other. So 3.0 minus 3.0 equals, sorry about that, equals 0, which tells me that a covalent bond is going to form. These chlorine atoms are going to share their electrons, and they're going to share them equally. So I'm going to draw my first chlorine atom. I'm going to draw a Bohr model of it. And so inside my nucleus, chlorine has 17 protons, and it's going to have 18 neutrons. And so the protons and the neutrons go into the nucleus. And around the nucleus are going to be our electrons, and they're going to be orbiting in their energy levels. So I need to have 17 electrons in my chlorine atom. And so my first 2 electrons are going to go in the first energy shell. 1, 2. Then I'm going to need another energy level because I need to have 17 electrons. So here's 3, 4, 5, 6, 7, 8, 9, 10. Oh, still not done. I need another energy level, 10. So 11, and I'm going to go this way, 12, 13, 14, 15, 16, and 17. So now I have my 17 electrons in their proper energy shells. And so in order to show the bonding, what I need to do is I need to draw another chlorine atom. And so I'm going to start my other chlorine atom over here. Actually, I'm going to erase some of what I wrote up here. Okay. And so now I'm going to start drawing my next chlorine atom. And so I have my nucleus. It has 17 protons. It has 18 neutrons. And I'm going to start drawing this 17 electrons that this chlorine atom has. 1, 2, 4, 5, 6, 7, 8, 9, 10. And now, since my two chlorine atoms are going to be sharing a pair of electrons, this outer energy level is going to overlap. Okay, and I'm going to draw the remaining 7 electrons for this red chlorine atom. So we have got 1, 4, 5, 6, and 7. So now, because my chlorine atoms are sharing a pair of electrons, my blue chlorine atom is sharing an electron with the red chlorine atom, and my red chlorine atom is sharing an electron with the blue chlorine atom. Each chlorine atom now has a full valence shell. If I count the number of electrons in my red chlorine atom, I have 1, 2, 3, 4, 5, 6, 7, 8. So that chlorine atom is happy. If I count the number of electrons in the valence shell of my other chlorine atom, I have 1, 2, get my pen, that will help. I have 1, 2, 3, 4, 5, 6, 7, 8. So both chlorine atoms are now happy because they have full valence shells. By sharing a pair of electrons, they were able to complete each of their valence shells. And so again, this is a single bond. It is a covalent bond because they are sharing their electrons equally, which means that we created a covalent molecule. There's no imbalance of charges because they're sharing their electrons equally. So that's what a covalent molecule looks like. That's how we show covalent bonds. And the first step is always to use the electronegativity values of each of the atoms to figure out what type of bond is going to be forming.